Hi, this video is called The World Famous Planet Killer and Conjoint Analysis. And what you're going to learn is how you can be more critical of some of the ideas or methodologies proposed in using conjoint analysis. Now our story starts back at the first discovery of the planet Uranus. It was discovered using a telescope because it couldn't be seen with the naked eye. After many years of observing the course of the planet around the sun in the solar system, it was time to compare and see how well Newtonian physics or Newtonian mechanics predicted where it would be in the solar system compared to where our actual observations were. And it turns out they didn't match. We were off. There was some reason that we were off. Now the most logical reason for it being off is that there was some other source of gravity that hadn't been accounted for, something beyond the known planets, and the planet Uranus was tugging on it, which made it take a different course around the sun. Now, no other planets had been observed, or no other asteroid belts. But some brilliant mathematicians said, hey, I've got an idea. Let's take these principles of Newtonian mechanics and work backwards with the mathematics. Let's figure out if there's something else in the sky, something else that's tugging on the planet to give it its course that it's taking around the sun. And doing a whole lot of math, what they did was they found that there's got to be another body out there somewhere. And one of them actually called an astronomer friend and said, hey, look up in the sky over this area at this time, you should see a planet. And he was really close. He was actually just a few, or just within a degree of where the actual planet Neptune was discovered. Now this is an absolute triumph for Newtonian mechanics. Using pure math, we were able to discover a new planet, the planet Neptune. Well, the story continues. Years later, taking a look at the planet Mercury as it travels in an ellipse around the sun, that ellipse turns ever so slightly every year. And that amount of turning, or that turning is actually predicted with the Newtonian mechanics, but the amount that it turns was off from what it would be predicted. Well, these same mathematical geniuses who discovered Neptune decided, hey, I know how to do this. Let's apply that same process that we did to figure out what was wrong with the path of Uranus and discovered Neptune to Mercury, and see if we can discover if there's an asteroid belt or another planet or something causing the course to be different than what was predicted. So they'd done a lot of math, working backwards, and about that same time, there was an amateur astronomer who he'd seen a massive body, a planet or something, cross in front of the sun at a certain time. This was great. This was all they needed. They discovered a new planet, and it fit with the math that they'd been talking about. They discovered a new planet and decided to give it a name, something nice, a nice hot name because it's so close to the sun, and they named it the planet Vulcan. Now there was a big uproar at the time about this planet. It was pretty exciting to discover a new planet without actually seeing it. See, there were contradictory reports. There were other people looking at the sun at the same time that didn't see the planet. And it was just, for the most part, it was chalked up to being close to the sun, lost in the glare, or for whatever reason it wasn't readily observed. But there was enough evidence, mathematical evidence, that the New York Times actually had an article that was making fun of the astronomers who didn't accept the existence of the planet Vulcan, mainly because they hadn't observed it with their own eyes. Well, it turns out Vulcan has been erased from the planet Vulcan has been erased from the history books, and it's been blotted out of the star charts. And it all happened when a young patent clerk published his general theory of relativity. That's right, Albert Einstein. Now with the new general theory of relativity, this planet near Mercury was no longer needed. The theory of relativity perfectly accounted for the change in this ellipsoid path of Mercury around the sun. Just like that, we've lost a planet. It's gone. Now, what does this have to do with conjoint analysis? So it turns out that Newtonian mechanics is a great approximation for gravity and how it works. And it works extremely well most of the time, except for when you get close to a massive body like the sun. Then it no longer works well. It starts to break down. The same thing happens in conjoint analysis. The statistical models and the methodologies that we use are grounded in some very robust theories. And these theories are very important to help us understand when an approach works and when it might fail. Now, a lot of times you'll see some new ideas or some new approaches that are grounded in theory, and that theory helps us to know when they'll work and when they might not. Sometimes you'll see some ideas that are just creative ideas, but they're not necessarily grounded in theory. You might have an anecdote of when they work, but you never know when they won't work, and that's the trouble. And that's why we have a hard time adopting some of these more creative approaches, or why we shy away from them. Okay, that's my whole story. Thank you.